This is Jenny Kunkel, and in this video we are going to take a look at views and materialized views. And if we start with our discussion on views, we need to think about our tables that we use in views as base tables. We have views that we can think of as virtual tables that are going to be created from a query of one or more of our base tables. When we create a view, it's not going to store any data. It's just going to store that view definition, that SQL statement. And when we select from our views, it's actually going to go out, grab that SQL statement, and essentially run that on request. Now, why would we want to use views? Well, they're going to simplify complex queries and provide an abstraction from the underlying table structure. And this is really a good thing when we have a composite type of information. Think about when we have order information, we have order header, we have order details, we have product information, we have customer information. We have multiple tables that need to be joined together to get that composite view of the order. And if we expect our user community to actually be able to join those tables correctly without potentially running into a situation where something doesn't get joined correctly and we get into having Cartesian joins that are going to impact the performance of our database, that is not something that is so great. And if we can simplify things and provide our users with the data that they need, but by accessing a view, it simplifies the way that they get access to that data. And then they can add in their filter conditions and they can order the data in any way that they need to. That's going to make things a little bit more seamless for the user. And we're assured that we're not going to have any performance degradation on our database. Now, another reason that we use views is because security. We might have a field in a table that shouldn't be seen by the users, and we can go ahead and obfuscate things by not including those sensitive fields when we create a view definition. Think about an employee table. Maybe somebody needs access to an employee table information, but they're not from HR, and we have a social security number that's in that table. We would essentially create that view without that social security number. They would be able to get the information that they need, but that sensitive data then would not be accessible to them when they're selecting against that view. So that would be a good thing. When we create views, it's essentially going to be create view with a view name as and our select statement. So that would be SQL Server. And we can join as many tables together as we need. So we can have a single table that we're creating a view from that has filter conditions with our where clause, or we can join as many tables as we need to together. A little bit different from SQL Server is Oracle, where we can either create or replace. So with SQL Server, we can just create it. With Oracle, if we have a need to update that view after we create it, we can just rerun the same statement because we have the create or replace view with the view name as and then the SQL statement. Now, when we are creating our select statements, one of the things that we cannot do is, for the most part, add an order by clause to the statement. There's like one or two edge cases, but just consider that you can't put it in and then you should be safe. In a lot of cases, we want our view to be created and then we can order it after we select from that view any way that we want. So we're not going to put the order by in the view. We would apply the order by when we're creating the select statement that contains the view definition that we're trying to execute against. If we need to change our SQL Server view, we saw before, we just have the create. We must alter the view. So we would have alter view with the view name as, and then we would provide our updated select statement of one or more base tables. If we want to remove a view, this is going to work similar to what we had with our create table, etc. It's essentially going to be drop view with the view name. We can also do the drop view if exists with the view name if we're using SQL Server or if we're using Oracle 23. Now in our case, we're using Oracle 22, so we would just be doing drop view with a view name in Oracle. One of the features that SQL Server has that Oracle does not is where we can set up a view dependency on the base tables. Now with Oracle, if we make a change, it doesn't necessarily register that there is a dependency. It's going to essentially invalidate our view. We're not going to be able to use it, but it allows us to drop something. So we could drop a table that a view is dependent on, and it's not going to give us any information. And if we create our view like we saw before with SQL Server, it's going to allow us to drop a view. It's going to allow us to drop columns from one of the base tables that are included in a view, and it's not going to care. But when you try to access that view, it's going to fail. One of the ways around that with SQL Server is we can add this with schema binding clause to our create statement. And then if we try to drop a table that's included in a view or alter and remove a column from a base table that's included in a view, it's not going to allow us to do that drop or alter on the base table because there is a dependency that's established, and we would have to drop our view before if we can go through and drop that if we create our view with that schema binding phrase on our view creation. Now with our views, in some cases, we can go ahead and do insert, update, and delete statements against views, but there are some caveats, and some of those with updatable views are the following conditions must be considered before we can consider our view to be updatable, and that is that our query that we use to create our view cannot contain a distinct or a top clause. It also cannot include an aggregate function. It cannot include a select list with a calculated value in it. It cannot include a group by or having clause. It cannot include a union-all, cross-join, except, or intersect clause. Now, it doesn't mean that we can't create a view, just means that the view will not be updatable. Now, with our update views, we have some issues, and we cannot delete from a view when the modification is going to affect multiple base tables. And I believe we're going to actually take a look at that. We also cannot insert when the view does not contain all the required mandatory fields in the view. So if we're trying to insert into an order table and we only have the order number and we have quite a few other fields like maybe our customer ID that's required and we don't have that information in our view, we left that column out because they didn't care about seeing the customer information, and we're trying to insert something into that view and we don't have that required customer in that view, we're not going to be inserting it. It's going to fail because the base table requires that that field value is provided, and that is a required field, and unfortunately then it's going to prevent us from actually doing the insert into that view. With Oracle, they also provide a materialized view, and this is a little bit different. You can think of a materialized view as more of a snapshot. So it is going to create a physical copy of the view data at a point in time. So a snapshot. When do we use this? Well, it's used to improve query performance. But this is in a case where the data is not going to be changing frequently and you don't need the latest, greatest updates in order for whatever the application that you're trying to use the snapshot for. So the materialized views can improve your query performance, especially when you have really, really time-consuming queries. Now, we've used this before when I was working at a manufacturer. We had some really complex queries that we were doing on our e-commerce site, and by using snapshots or these materialized views from the Oracle side, we were able to improve the performance because initially it was taking like 20 minutes to run a query to get the information. We could get it down to like 1 minute or less in order to do that. So from the user's perspective, that was much preferable to do. Now, when we create our snapshots, that's essentially the data is frozen. We don't change the data within our materialized views, and it's not going to reflect the most current changes. If we want to reflect those most current changes, we would have to refresh the materialized views so that it has a new snapshot that it's showing us. When we create our materialized views, we essentially say create materialized view, give it a view name. So that's pretty much like we did with the views. We need to tell it to build either immediate or deferred. Typically you see immediate. And then you need to provide what type of refresh do you want? Do you want it to be fast? Do you want it to be complete? Or do you want to force it? And in the case of most of the times, if you specify complete, it's going to use fast to try to do that refresh. And if it can't achieve the fast, then it'll go through and do the complete. And then after you specify all these parameters, you say as, and then it's going to contain your select statement. Now to refresh that snapshot, you use the dbms_snapshot. This is going to be a database package that has a procedure, which is a refresh, and you provide it the view name, and then it's going to essentially update that snapshot, re-execute that SQL statement, save out that data, and then the next time that you refer and select from that materialized view, you're going to see that new updated snapshot. And we're going to go ahead and switch to SQL Server now, and then take a look at views there. And then after we're done there, we're going to switch over to Oracle, take a look at views and materialized views there. Okay, in SQL Server, we want to go ahead and create a couple different views. The very first view, we want to do it based off of our puppy table, but we don't want to exactly use our puppy table because we're going to be deleting columns, etc. So I want to go ahead and create a copy of my dbo.puppy table, and I'm going to do that by doing a select into statement. That's going to give me a copy of that. If I go ahead and refresh this, I should see now that I have in my tables the puppy temp. Now I'm going to use that to create my view, and I can go ahead and specify create view and give it a view name. So let's call this VW_puppy temp, and this is going to be as. And then we want to explicitly call out the columns, and in this case, this is going to be puppy no, comma, puppy name, comma, kennel code from the dbo.puppy temp table. I'm going to go ahead and create my view, and if I refresh and look at my views, I should have that view. Once I have my view defined, then I can treat it like a table, even though it's really not. It's not storing any data, but I can call it out in a select statement like a table, and I can specify my dbo.vw_puppy temp. When I do that, I can execute it. It's essentially going to go out, get that query, and then it's going to run that query. Now, if I decide that I want to put any filter conditions on that or order it, it's going to apply those after it gets that query. So I can do an order by puppy name. When I do that, it's going to reorder by the puppy name based off of that query that was stored in the view. So that's going to be one of the things that we can do. But what happens if later on somebody comes in and they're like, we're not really doing anything with the kennel code. We really want to drop it from the actual underlying dbo.puppy temp table. I can do that by altering the table, and this is going to be the dbo.puppy temp. This is the base table that our view is created from, and we're going to drop column kennel code that's in our view. So if I go ahead and I alter it, drop it, that's okay. Now if I go ahead and try to rerun this query, it's going to fail because the column is no longer in the table that we're referencing. So this select statement doesn't work for us anymore. We would have to change the view if that was truly the case. But that's not great because now it allowed us to make the change. We don't really know about the fact that we have a view out there until we would happen to hit that and we would have some type of an error condition come back. Not ideal. So let's go ahead and let's drop that view. So this is VW puppy temp. So I'm going to go ahead and get rid of that. Now that I have the view dropped, I want to go ahead and drop the table. And this is going to be dbo.puppytemp because I want to recreate it. Dropping the table. Must have gotten rid of it. Let's copy it back in. The select statement that's going to create my table copy. Let's go ahead and execute that. Now we have that table. We can go ahead and specify with schema binding. This is the clause that we do not have the capability to do within Oracle. If we go ahead and create this, now we have our view that's based on that underlying table. I can still go ahead and select data from it. That works. Now, if I try to alter that table, what happens? It doesn't allow me to alter the table because it's telling me that I have an underlying view that is using that column in its view definition. So that's going to be a little bit of something that's going to protect us from ourselves. Now, the next thing that we want to do is we're going to do something a little bit more complex. So I'm going to go ahead and just get rid of all this. And I'm going to use the select statement that has a join. So it's going to join between puppy and the kennel table. So if I execute that, my query is actually working. So I can go ahead at this point and wrap it and create a view. So create view. I'm going to call this VW puppy kennel as, and I'm not going to bother with this with schema binding on this. Going to go ahead and execute that. Now I have my view defined and I can use that view. So I can select against the view. And it's going to give me everything nicely and I don't have to join anything. I could then go ahead and add my filter conditions. I could do my auto reply clause, whatever. Now, say I decide that I want to insert a new puppy. I can go ahead and insert into my view, VW puppy kennel, and specify the fields that I want to go ahead and specify, like puppy name and kennel code, and provide the values. In this case, this is going to be Lucy, and she is going to have kennel code 1. So that's what I want to provide for my insert. If I insert it, it's going to work. I can then select it again and see that I now have Lucy in there. But what happens if I want to change from the kennel code 1 to kennel code 2? I can do an update VW puppy kennel, set kennel code equal to where puppy no is equal to 5. So if I execute this, it works. And then I should be able to see that this was updated. But what happens when I do a delete? We saw that there were special underlying circumstances. So we're going to delete where puppy no is equal to 5. If I try to do that, it's not going to work. I would have to do that from the base table because I have essentially a join condition and it doesn't allow us to do the delete because the modification would affect multiple base tables. So that's something to note. Now we're going to go ahead and switch over to Oracle. In Oracle, the very first thing that we want to do is we want to write the select statement that we want to use to create our view. So we write it, This is going to be more complex. We're joining our orders with our customers, with the stores, with the order items, with the products, with the shipments. And we can see here that we're using inner joins. Maybe this is going to give us everything that is either in transit or delivered. It's not going to give us things that haven't necessarily been shipped yet. Maybe we want to change the view after we create it. We're going to go ahead and create it initially using this query. So this is going to be create or replace the view, and this is going to be VW underscore order info. And then we're going to go ahead and select this as the select statement. So once we do that, we can create our view. The view's created. We can go ahead and select against our view. Run that, and we can see the data. We see things that are delivered. We see things that are in transit. We don't necessarily see things that are null because we have used the inner join on that shipments table. Maybe we want to change this to be a left join. And when I change it to be a left join, I can just essentially change the SQL statement and rerun my query, and it's going to update, and then I should be able to execute this. And if I scroll over, there should be things in here that are null. Assume that I want to use my initial select statement that's using that inner join because I don't care about things that haven't quite shipped yet for my materialized view. And when I create my materialized view, this is going to take a snapshot. It's going to take a snapshot of the data at the point in time. So I can go ahead and paste in this. I want to create my materialized view. I'm going to call it MV underscore order underscore info. I need to specify the build. In my case, I want this to be immediate. I need to specify the refresh. And in this case, I'm going to use the complete. It's going to essentially do the fast if it can. Otherwise, it's going to do a complete refresh. I'm going to specify as, and then my SQL statement. I'm going to move this down just a little bit here. I'm going to go ahead and highlight this and create that materialized view. Now I can go ahead and select asterisk from that materialized view, the same as I can from the view. It's going to give me the data that was essentially that point in time view of the data. I'm going to move this down here to be closer to my materialized view. But at some point, we want to update one of the in-transit records, and we can do this using an update statement. And this is going to be updating the base table, which is going to be the shipments that is part of that view. So we're going to change that to delivered. It's originally at a value of so let's take a look at what it is to begin with. Let's put this clause down here as well. We look at this here in the view. We see that it's in transit. If we look at it in the materialized view, it's in transit. If we update the shipments to delivered and execute it, if we look at it in the view, we should see that change reflected. It's showing us delivered. If we look at it in the materialized view, it's not showing the update because it's showing us that point in time view that it took a snapshot of. So how do we go about updating our materialized view? Well, we can run the dbms underscore snapshot dot refresh that package and its procedure. So dbms underscore snapshot would be the package name, and then the procedure within that package is the refresh. We put that between a begin and end block to run that procedure, execute that, and it's going to update our snapshot and give us the most current snapshot. So I can go ahead and then rerun this. And this time when I do that, it should show me that it is delivered. So that is showing the most current data. So think about that from the standpoint of if you have an application, it has a bear of a query and you don't need the most timely information, you can use a materialized view and then put it on some type of frequency. You can store something and run it on a database job on some type of a timed frequency that it's going to do those refreshes for you. Now, I can drop my view, and the view is the VW order info, same as what we saw in SQL Server. I can also go through and drop my materialized view, and this is MV underscore order info. And that is essentially what we're going to cover in our little walkthrough in Oracle.